an important
and it
building
makes
and
clear,
event,
you've made
you know,
clear that they
so,
should be.
Yeah, of course.
Hi.
Yeah.
You mentioned something like a fuse zone in your structure for dissipation of the energy and damping.
Mm-hmm.
Can you clarify exactly what you mean by that? Thanks.
Obviously, you have the link beam is the area where you can control how much bending the overall core is going to take. But most of these buildings, essentially, they are not. Bill is here, can answer that too. But essentially, these buildings are not necessarily controlled by tall buildings, by local effects. They are mostly controlled by the overall displacement of the tower, and this is how they dissipate their energy. So essentially, the link beams are the locations where the fuses essentially are. In other words, the ductility of the link beams, if you can limit how much force that these beams can take, essentially you can control the overall bending and the shear of the building. Yeah. But Bill, you want to add something to that? Yeah. Okay. Yeah.
From a purely engineering point of view, given all the restraints that you mentioned, the hydrolysis analysis, the most dramatic seems to me the wind vibration, the higher, the more difficult to control. Are there any conceivably limit as to the height? In other words, today you got 160 floors. There are places where they consider 200 floors, or could it be possibly 300 or 1,000 floors? Is there possibly, engineering point of view, a absolute ceiling?
Of course, I mean, structurally we can do anything, you know, as long as you have the cost, right? As long as you can limit the foundation pressure and how much you can limit it. Practically, this building, if you look at the foundation pressure, is not any different from any building that you have in terms of pressure. So the base, the aspect ratio become extremely important. But obviously there are other things that become more critical, such as the elevating system. Are people comfortable going up and down? And well, essentially, I mean, you can manage. Obviously, there are construction technologies. There are limits to the material. For example, if you take Burj Dubai and you look in how the system is managed from a structural engineering standpoint, you get some of the elements are the same size from bottom all the way to the top. So gravity management and how you do that become extremely important. I mean, from a construction standpoint, it's just fantastic. If I can take the same formwork and carry it all the way up without changing its width or length, and by just managing, by just adding more elements and managing load to it, it's like building a pyramid. You know, you keep going out. You know, and but obviously there are environmental issues that has to be looked at and see, you know, from design to design. You know, like this building, it happened to be an excellent, and from an environmental standpoint, because it doesn't, the depth, the natural light, everything is provided. Other buildings, they don't have that luxury of get a lot of natural light. So it depends on the planning of a particular building. But essentially, I think you can go higher, much higher than that. Yeah.
Please.
Yeah.
Can you comment on GPS system in which you have fixed points 1, 2, and 3?
Can you ask the question again, please?
Can you comment on the GPS system,
okay,
in which you have fixed points 1, 2, and 3?
1 and 2.
Yeah. Fixed points.
Yeah, yeah.
You have fixed points.
Yeah, yeah. Obviously, we have the rover is moving, right? So when the GPS is getting the XYZ of each point, right? And then at the same time, you have to have fixed positions that are not moving. And the difference, you can calculate exactly what that is between the two, because you're getting simultaneously the position of the tower, you're getting simultaneously the position of a fixed position, and you have 6 others just for quality control and checking, just to make sure that we are not only depending on one location. In case something happened, something moved, we have other points to look at for consistency. Okay.
I was wondering if you could talk a bit about the security, essentially, aspects of it in terms of fire or potential terrorism, because I know that Dubai is also trying to become the world's largest aerial hub, which I think Americans would scare them a bit. And then, of course, the idea of a fire on the 40th floor where all of the residents are above that, I think creates its own problems too.
There's a lot of planning. Probably Bill had talked about that last week about the probably related refuge floor. You want to answer that?
Yeah. Basically, there's a refuge floor at maybe every 30 floors, or there's about all the stairs are concrete encased all the way out. And where the wing sets back and the stair exit has to move back into the building a little bit because the wings is where you have to transfer from one stair to the next, and you create a refuge floor there. They're also looking at lifeboat evacuation, where you actually use elevators if the fire marshal says it's okay, so to bring people out using there from various levels, which correspond to the refuge floors. So that's kind of the approach that was used on this one. Well, I can't remember. The question was how many people are in the tower for evacuation, and I don't really remember. It's primarily residential, so the numbers you use for evacuation calculations are a lot more people than are probably actually in the tower, just because of the code requirements on it. But to be honest, I can't call a number to mind.
Obviously, there's a lot of refuge area where you can protect the people and hold them until you're ready. It's not like everybody is going to leave at the same time. And as you can see, also the structural system itself is very, very redundant system. So potentially there's a lot of loader distribution into, but that can be.
Hi. Oh, sorry.
Thanks. Thank you for your presentation. I'm not in this industry, but I'm going to go there in about 2 or 3 weeks, so I was curious about anything about this town before I get there, so I know what to expect. Question for you. I thought I saw conflicting information. Is the budget for this building $1 billion or $20 billion? And the second question is, can you go into some of the background of the Emaar company, the ownership? So the price differential and the budget, and then
the first number, 20 billion, is the entire development that you saw: the residence, the townhouse, Burj Dubai, the Dubai Mall, and all of the other adjacent facility over the entire area. The tower itself is 1 billion, so it's only 1/20 of the total cost of the development, the entire development.
And then the Emaar
well,
company?
Emaar is really a public company, essentially, and it's backed by the government a little bit. And they do a lot of, it's one of the biggest developer in the world, especially related to large mass developments. Anywhere from Dubai, they're expanding into Pakistan, India, into a lot of other places around the world, North Africa, some of the U.S., I think even European. So they are expanding everywhere internationally.
Okay, thank you.
Okay.
Hi. I was wondering, what's the reason for switching from concrete system to a steel system, and why at that level that you chose?
Can I answer? Okay. Bill can answer, but essentially, if you look at the setback of the building, it's a construction. I mean, the climbing foam system works fantastic up to a certain level. Once you go beyond that, once you start cutting it off, then it becomes very difficult to manage. And the structural steel was a natural way of going into that. Bill, you have to add?
Yeah. Basically, the building keeps getting smaller and smaller, and eventually it got so small that it didn't fit within the standard formwork. And so when you're doing things that are non-typical, it's easier to do that in steel. But you have something that's quite repetitive, and it's easier to do it in concrete. And so at a certain level, it got within what we call the axle or the hub, and it was setting back into the hub. And so the concrete approach didn't seem reasonable anymore from a construction point of view.
Did they have any structural differences as far as performance? Or
no, it was just a standard, they had to transition from the steel to the concrete, so you had the details, and, Samsung and SOM went back and forth several times on how to do it, and I think we're still talking a little bit, but
Yeah.
but yeah, it was pretty standard approach how you would do it. I mean, it happens here in New York where you're like up at Columbus Circle where you have a steel building below and a concrete building above, at the Time Warner building. So I mean, it's there's methodologies to deal with these transitions.
Thank you.
Plus the fact, as Bill mentioned, I mean, you get so many variation. It's very difficult to do it with any kind of formwork system without losing a lot of time. Floor-to-floor heights are very high, very difficult to do in concrete. So you just steel is a natural.
Thank you, Ahmad, for the wonderful presentation. I have a question. One is, because I missed the last seminar, I wonder what was the estimated the peak acceleration at the top occupied floor, and second, and then the Samsung will instrument the real time acceleration on that at the most top floor. Okay. Second question is just I think I experienced on the John Hancock in elevator, because the reason due to the fact this building is so high rise, 700-meter tall. How long take to get the in a high floor, and then do we anyone consider some environment or some phenomenon to the person ear pressure difference? Because I experienced some ear pressure difference while you're moving that so fast.
Yeah. Well, to answer the first question, probably Bill has the up-to-date acceleration, but I think it's within less than 15 millig's, right? If it 20 millig's, about 20 millig's.
Yeah, the peak for the residential is around 7 millig's, and the peak for the office and I think above the office is it's in the low 20s. As far as accelerations, and that's with just inherent damping without adding any devices. It's just the wind was so disorganized that we didn't get large accelerations. And I don't remember the other questions. But you?
Okay, the second question, I think.
So you're going to instrument like all acceleration
in terms
through
of
the
at some point,
light.
I'm sure we will definitely have a real-time monitoring program instrumented at some point. That's for sure.
The whole the building lifetime?
Yeah, why not? I think because with the present technologies that we have, almost you can put something in the building and you can get to the data anywhere in the world. As long as you have things are pretty much set up and all the routines are in the computer, once you get the data automatically, you can process it and feed back the information. I think that's a real thing. In terms of the elevator, obviously going up, usually the pressure goes down, so it's not a problem. So there is the elevator speed is about 600 meters per minute, so practically you can reach to the top very quickly. But coming down, usually in a very tall buildings, you have to be careful. There are two things. One, you have to slow down because of the pressure sometimes. So as it goes up, much be faster, but going down, maybe it has to be slowed down. The other thing is relative to, as most of us know, relative to the wind. If the wind is too high, then you have to be careful. There's the elevator themselves have their own system. After a certain movement and after a certain level, they can slow down the elevator in there.
Thank you.
Okay. Yeah.
One more question.
Okay.
Just a quick question. This is probably the largest construction site, if not one of the largest ones in the world right now. I'm just wondering what kind of a safety record has there been and what kind of safety considerations were taken into account before the project even started going under construction?
Well, obviously, safety was one of the most important things that we considered, including quality control. And we tried everything we can to make sure that the workers are always safe. There's, as you can see, a lot of the extra costs that we have to incorporate in closing the building during construction for the worker to protect them against safety is one of our utmost consideration for the project.
And has there been any kind of casualties at all, or? Has it been pretty safe overall?
Well, obviously, any site there are accidents, you know, that happen, you know. So.
Thanks.
Okay.
So we
Okay.
invite you to come to the reception, which is just outside here, and continue to ask questions. And please come back on July 18th.
Well, thank you very much.